Hello, I'm Michal Okoniewski. I'm Chief Science Officer of Accelor. And I have with me today Pete Sametz, Executive Chairman of Accelor. Welcome, Pete.
Thank you very much, Michael. Let's start with a general question about how does this process work? And for most people, they may already know we're thinking of drilling a horizontal well into a heavy oil reservoir, viscous reservoir, and then we'd add our second well, which has two legs to it, with essentially RF antennas. So how does this process work?
Yes, so most people are very familiar with how microwave ovens work and how they can heat any food that contains water. Essentially, this is the same process. We are really heating water which is already present in the reservoir. Not water that we inject from the outside, but water that is already present. And by heating water, we heat indirectly other materials in the reservoir. The way that works is that we have those two antennas, as you said. We actually don't call them antennas. They don't quite act as antennas, but nevertheless, the energy, the electromagnetic energy we inject into the well moves along those two radiators and
Right.
heats entire area in the
So,
volume.
so it'll move along the horizontal well, heating
It
the
will first
oil.
move along horizontal wells, and then it will start spreading away from horizontally away from those two legs.
Okay. Yeah.
Pete, now you know how excited I am about this new technology and
Yes, I do.
and how simplified it is with respect to anything we have seen before. But given that what you know about the way we want to deploy this, what would be the ideal reservoir and what would be the best farm-in on joint venture scenario here?
Well, first of all, I'm quite excited about the technology as well. When I came on board just 3.5 months ago, so I understand it, and I think it's really going to be something that moves the recovery factors in heavy oil in Western Canada. Um, Ideally, what we'd be looking for is, and we're talking to a number of companies now, both small and majors, in terms of farming into existing lands, both in the Lloyd area as well as up in the Blue Sky country up near Peace River. But the intent here is to get into a reservoir, drill these wells, test the process. Essentially, it's a commercial demonstration project, and effectively take a reservoir that's been bypassed or left behind. It was maybe attempted with horizontal wells, produced 0.5% or 1% recovery factor, but the oil was just too viscous and it watered out, or it was just too viscous. So if we can find, and what we're after, what we have a bunch of targets, is essentially to get something that's probably 50,000 centipoise or higher, maybe no more than 100,000 centipoise. And that's a term for how viscous the oil is. Um, there's enough thickness to drill the horizontal wells, and essentially we can increase that recovery factor by heating up that oil. And viscosity curves in some of these areas, as soon as you add enough heat, you get oil that flows quite freely. So let's increase the recovery factors dramatically overall.
So essentially, you're looking for reservoirs that at this point cannot be recovered using any other technology.
Yeah, that's it. We believe there's billions of barrels of bypass pay in our Western Canada basin that have been maybe attempted on primary production, uh, but they really didn't produce hardly anything at all because of the viscosity of the oil, and by heating up the oil in situ in the reservoir. But just to be clear, we're not competing with SAGD or steam assisted gravity drainage, which are taking thicker reservoirs and injecting steam and heating up the oil that way. We're going to heat up the oil with our radio frequency energy.
So most people who are experienced in oil and gas, I think, understand very well that if you deliver heat to a formation like that, you produce oil.
Yes.
And so that's our primary goal, to really deploy heat in the reservoir and then decrease viscosity and then have the oil flow. What is the drive, really main drive in your mind that is going to produce oil here?
Well, a couple things will happen once you introduce heat into the reservoir. One is the viscosity will drop and the oil molecules will flow more freely, but the productivity or the production of the wells will be dramatically different. But to be clear, we're not injecting steam or doing a pressure maintenance scheme. So essentially, this is a way to get our recovery factors under a primary system to more normal numbers, whether it's 10 or 20%. The opportunity, once you start doing this and it's working fine, is that you can always add pressure maintenance through different means, but you can always add pressure maintenance later. So if you want to keep the reservoir pressures up. But the way it's constructed right now on our first commercial demonstration project, it will be essentially a primary recovery process with oil that's not very viscous. Okay, so Michael, we are talking with different companies about putting our system into play in
Yes.
various reservoirs. One of the questions that comes back all the time is, and it's just how much power do you need to put into the ground,
Right.
and how does the heat propagate in the reservoir? Like what actually happens dynamically once you start heating this stuff up?
Yes. Thanks, Pete. These are actually two different questions, so I'll try to address them one by one. We need to have somewhere between 2 to 4 kilowatts per meter of the well. So ideal well lengths for this process is somewhere between 800 meters and 2 kilometers. This has been designed from the very beginning as a technology that
So we could do long
we can
horizontals.
do very long horizontal. We designed this technology with very long horizontals in mind. And right now we are targeting 800 meters length, more or less.
Right.
And that's because that allows us to use a 2 megawatt generator, which we call CTI, Clean Technology Inverter, that really addresses this length of well in the most optimal way. But we could increase the amount of power that we deliver to the reservoir to 4 and even 6 megawatts. What drives the amount of power required is the length of the reservoir,
Yep.
is the viscosity of the oil
Yep.
that we're dealing with, and the amount of space I, as an engineer, get to actually drive power down. So basically, the more power we need in the reservoir, the larger diameter of the well I will need to have to drive enough power to heat it up.
I see. And you're referring to, of course, the heater wells or
That's
the
right.
antenna wells.
That's right. I'm referring to heater wells and specifically to coaxial cables that actually drive power down.
Right.
So as an example, when we're working with 2 megawatt system in the new version of the technology, those cables that we'll be using to drive power down will be of 2 7/8 diameter coil tubing cables. But if we were to increase power to 4 megawatts or 6, we'll probably go to 3.5-inch diameter of those two coaxial lines.
So I understand we've simplified this system from the original testing to our version 2.0. Do you want to just elaborate a little further on that?
Yeah, this is. Thanks for the question. I'm really excited about it. When we
So am I.
when we designed our first system, so 1.0, it was already much simplified with respect to anything that has been done in the past. But it still relied on joint tubing, and that process is expensive. It requires a long time on the rig, and it's still potentially difficult because of the, every joint tubing has to be torqued up to appropriate level. So it's
Exactly the same and not leak as a result.
That's right. So we found a way to instead utilize coil tubing. And by doing this, we essentially have not a single point through which water can actually get into our system.
Right.
And not only that, but it's also much simpler and much faster to deploy.
Right. And I understand we've also introduced some new technology in terms of the cabling itself.
Yes. When we started with this technology, we just couldn't find a manufacturer that would produce cables to our specification. But as it is with technology, now we have such a possibility and more than one place in which we can manufacture the cable that we need for this.
And it deploys the energy more efficiently to turn into heat than what we had before.
Yes, it utilizes a simple, let me put it very, very simply. This new technology that we're using utilizes copper that you deploy in our cables to a much better degree. So because of that, we can actually use much smaller diameter cables.
Right. And reduce the overall costs.
That's right.
Yeah.
Thanks, Pete, for this conversation. You bring wealth of experience in oil and gas that is tremendous to this company. Stay tuned for more information about our projects.
Thanks.